Hello. Can anyone hear me, please?
Yes, I can hear you. This is Jorge.
Yes, we can hear you, Helen. So we will get started in a minute. Yeah, okay. If everyone in the room now can please take your seats.
Okay. Good morning, everybody. If you could take your seats, please. Okay, good morning. So today we have a little bit of a special extra contribution this morning. So we have Helen Beggs, who's recently retired from the Bureau of Meteorology, is going to give us a little bit of a story of GHRSST over the last 20 years or so. So Helen, it's nice to see you, and yeah, please go ahead.
Thank you very much, Anne. Hi. As you were just told, I retired from the Bureau of Meteorology last March, and for GHRSST26, I was asked to prepare a short talk about my experience with GHRSST. I'm really sorry I can't join you in Copenhagen this week, and hope you have a lovely canal tour today. I had an amazing time at the last GHRSST meeting I attended in 2023 in India, even getting to Garba dance at the conference dinner, which was really fun. And so I enjoyed it so much that I danced at the Garba party next to the hotel on the Friday. Next slide, please. After starting at the Bureau in late 2003, I first met the GHRSST pilot project science team in 2004 at the Townsville, Australia meeting. My boss, Neville Smith, sent me to GHRSST5 to investigate methods to convert the Bureau's global weekly 1-degree SST analysis, used at the time as a boundary condition for NWP model, to high-resolution daily foundation and skin SST analyses. At GHRSST5 and in 2005 at GHRSST6, I was delighted by a welcoming atmosphere and generous advice. I was struck by the time spent discussing important matters like how to define SST and what should be in GHRSST files. Joining the science team in 2005, one of my first tasks was to help to develop the GDS specification for L4 products. Next slide, please. Next slide. Next slide, please. Yes, thank you. GHRSST8 in the which was held in the Bureau's Melbourne office, was a great chance to introduce my Bureau colleagues to GHRSST, including having Andy, John and Eileen from NOAA work with Leon on MTSAT1R skin SST processing. Just after GHRSST8, my daily Ramsar SST analysis was made operational at the Bureau. It was formed at that time from SSTs from from in situ platforms and AMSRE, AATSR and AVHRR satellite sensors. But there were problems with SST data available around Australia at the time. A real-time observations from ships were sparse in 2007, and these were not from calibrated sensors. Also, the Australian locally received and processed HRPT, AVHR, SST data had high uncertainty and were hard to use formats. Luckily, in 2007, I obtained IMOS project funding for the Bureau to operate 2 sub-facilities to improve ship and satellite SST products over the Australian region. These aims were achieved over the next 18 years through extensive collaboration with GHRSST colleagues, in particular Ian Barton, Fred Wimmer, Gary Corlett, Prasanjit Dash, Andy Harris, John Mataz, Chris Merchant, and Owen Embury. Next slide, please. When the Bureau released a global daily L4 product called GAMSA in July 2008, I became more involved in activities of the GHRSST L4 intercomparison working group, which helped the Met Office to develop a GHRSST multi-product ensemble as a median of 11 global daily high-resolution SST analyses, including GAMSA. The aim of GIMPI was to provide a gap-free source of validation SST, and I have found it extremely useful for identifying issues in operational GAMSA throughout the years. At GHRSST12, the IC tag talked about 2 papers to write, one led by Matt Martin, describing and validating GIMPI, and the other led by Prasanjit Dash on comparing several SST analyses, including GIMPI, using NOAA's SST quality monitor called SQUAM. At GHRSST20, I formed the GHRSST climatology and L4 intercomparison task team with Shuzu Yang as co-chair. One of the first tasks led by Shuzu was to compare 8 long-term global SST analyses, including the Bureau's monthly SST, to assess their suitability for climate analysis. The resulting 2021 paper involved 16 co-authors and is widely cited. Next slide, please. Although from 2008 the Bureau produced foundation SST analyses, we were still interested in a diurnal thin SST analysis, but that would require finding a really good SST DV model to use. In March 2008, at the Ocean Sciences meeting in Orlando, GHRSST held an SST session. It was here that the GHRSST TWP Plus project was born and evolved at later meetings, particularly at the 2012 GHRSST Joint Working Group workshop on tropical warm pool and high latitude SST issues in Melbourne, which many of you actually attended, as you can see from the photo there. The aim was to put together a TWP plus data set of hourly MTSAT1R skin SST and hourly NWP flux data on a common 0.05 degree grid and period. The chosen TWP plus domain, as shown in the top figure, captured much of the warmest SSTs on the globe. From his PhD, Haifeng Zhang published 3 papers on tonal variation using the TWP plus data set. And I put the citations down the bottom there. Next slide, please. Okay, so what next? In late 2023, Pallav Vigovica, my colleague from the Bureau, joined the GHRSST science team, followed in 2024 by another Bureau colleague, Haifeng Zhang. Pallavi now leads the IMOS SST products, and Haifeng leads IMOS SHIP-SST sensors project. With my retirement from the Bureau last March, my operational involvement with GHRSST comes to an end, but I hope to keep in touch. The GHRSST meetings were the highlight of my 22 years at the Bureau. My SST research would not have been possible without the many generous collaborations and visits from GHRSST colleagues and access to the data sets from GHRSST and online tools. Please come and say hello if you're ever in Melbourne, and I can be contacted on LinkedIn or email or Facebook. Thank you so much.
Thank you so much, Helen, for giving that overview. We'll definitely miss you. And yeah, I do hope we see you again at GHRSST.
Thank you.